very good morning to one and all, and welcome to the final day of the 2-week-long yarn course. With this, we'll start our morning session for today, and I request Dr. Hitesh Handler to deliver his lecture.
Good morning, guys. Thanks, Neha. Welcome for the last day. So there are multiple small topics today I want to cover. First, let's wrap up the proposal writing that we were talking yesterday. I hope you remember we were talking how NIH has 27 institutes. Depending on your area of research, you submit your proposal to a particular study section. Depending if the score is good, the institute that's relevant to your work funds your work. Okay? And how, although the whole package is almost 100 pages, a lot of those are facilities and resources, vertebrate section, CV of the PIs and co-investigators, budget justification, support letters. Even though we need all that, it's essential. If you don't submit any of that, your proposal will get rejected. But most important document is your science. Now, for R01s, SBIRs, R21s, whatever type of, most of the proposals that we submit, they all have a specific aim page, which is a one-pager document that you are summarizing your whole research. So this is a proposal that I submitted few years ago, and this is an R21 example that I can little bit share it with you. Now, the idea of this proposal was, in simple words, that we want extracorporeal circulation. Now you know what that is. Blood is coming outside the body, going back inside the body, tubing is there. We wanted to make it nitric oxide releasing extracorporeal circulation tubing with zwitterion top coat. Okay, who can tell me now? You guys took the exam yesterday. All of you who are here today, they scored really well in the exam yesterday. So you can tell me what's the benefit of using nitric oxide releasing zwitterion coating for this surface. So nitric oxide can prevent platelet activation, it can kill bacteria, but it does not prevent protein absorption. Zwitterion will act as an anti-fouling surface, making the surface hydrophilic, so protein and bacteria won't stick to the surface, and even blood. So you have a dual action coating that synergistically will be better than only nitric oxide or only zwitterion, right? So that's the benefit of this. So see, my first paragraph is extracorporeal devices, infection happens, clotting happens, bleeding can happen, and it's an issue. Second paragraph is, from our past NIH grants, we have developed this nitric oxide releasing surface and we are working on zwitterion surfaces. So the third paragraph, the objective is to look at the synergistic effect. Hypothesis is, we believe that combination will be better than only NO or only zwitterion, right? So in a very simple language, you are trying to tell your reviewers, scientists, but scientific language, you are explaining your science. Then I'm saying, here is my specific aim 1, here is my specific aim 2, that will help me show this synergy. My aim 1 is, I'll make the NO releasing surface and I will covalently bind zwitterion surface. And then using nitric oxide analyzer, contact angle, UV vis, FTIR, atomic force microscopy, I'll characterize my surface for right amount of NO release, right amount of contact angle, how smooth my surface is. I'll use these techniques to optimize my surface. Now aim 2, after I have optimized my surface, I will coat the tubing. For aim 1 is, I'll test in vitro work. in vitro studies. Like I'll test my fibrinogen and platelets, I think. I have not looked at this for a very long time. So yes, fibrinogen and platelet adhesion. So we are not talking about infection in this proposal, it's just clotting. Clotting is a big issue. So I look for fibrinogen adsorption and platelet adhesion, and after my in vitro studies look good, I will test it in the 4-hour rabbit model that we talked about, the ECC rabbit model. I'll test it in that. And with the success of this proposal, this data will help me develop devices that I can test in larger animal models in an RO1 application, which is a bigger 5-year proposal. So this is an example of a specific aim page. I understand proposals you write in India might be little different, but I cannot imagine them to be too different. Science is same everywhere, right? Maybe you need to have certain headings that you need to put things under, but the meat of the documents will remain very similar. Now I will show you the research strategy document. This is for R21 6 pages, okay? But again, for your proposals, you might have a 15-page proposal or 5-page proposal. To give you an idea, I submitted this one type of proposal 3 times and I didn't get it funded all 3 times. It's called R35 proposal. It's a $6 million grant for 7 years. Okay, so almost $1 million or maybe 7 million, something, $1 million every year, $1 million every year for 7 years. Okay, but guess what? The science document is 6 pages. So you are writing in 6 pages, convincing the reviewers to give you $7 million for next 7 years. I think this tells us the power of writing. You know, this AI and all this is great, but you still have, each page is worth $1 million. Every word, I don't know how many words in a page, you can imagine every word is worth thousands of dollars. So you have to write that 6 page so well that reviewers are ready to give you $7 million. Now you see, I told you significance, innovation, and approach are the main subheadings we have. It might be similar or little bit off for you guys, but you can definitely think there is a lot of correlation. Even if you write a proposal in India, I have never written one, I have never seen one in India, but you need to say what your science is, you need to say why the project is innovative, you need to say what do you expect from it, probably you need to say what are the alternate strategies to do some things. Have you guys written proposals in India?
Right, Mark.
Okay.
So in that proposal, they ask for what is the global going
Impact.
yeah, and then the national thing, and how it will help the national.
Okay.
More focus is on India.
Okay, request. So you need to say why nationally and internationally this work is worth funding, right? So for example, for our type of work, it's easy, right? National or international, clotting and infection and extracorporeal circulation and hemodialysis is needed everywhere. What else did you guys, how else Indian proposals are similar or different?
And also then you have to justify your budget with every experiment.
Oh, so you need to, okay. So US Army, so NIH is little bit, yes, okay, in year 1 you will use this much money. So we have to do similar things. You know, in our budget here also we have to say how much funds will be used for animal work. But if you have a proposal like US Army proposal, they are even more stricter about it. Like you have to list all the reagents you will be purchasing. Okay. Okay, so NIH is little bit lenient on that. If you are under certain budget, so for example, if you are, I'm just saying a number, if you are up to $2 million, you can just put big budget. You don't need to go so nitty gritty details. But if you're asking $2.5 million, they want more justification that why you are going beyond the regular budget. Okay. Yeah. But science-wise, how do you think the proposals are similar or different? Let me go through this and then tell me what you think, okay? So, significance, we are expanding on extracorporeal circulation, thrombosis, how much bleeding happens, how much thrombosis happens, how different types of coatings have been used, heparin surface is used, but what are the challenges with heparin that's used, heparin induced thrombocytopenia is there. So we are just explaining why there is a need for what we are doing, right? And then we are saying how for coagulation, zwitterion can help with fibrinogen, nitric oxide can help with platelets. And ultimately we can prevent or reduce clot formation. So we introduce nitric oxide then in this paragraph. Then we introduce zwitterion. We say how nitric oxide does not prevent protein adsorption. We need zwitterion to do that. And then we write innovation, just simple innovation, that hemocompatibility of polymeric surfaces used in medical devices is highly dependent on suppression of contact coagulation pathway, plasma fibrinogen contribution, and platelets. We need to take care of both. Innovative aspect of this project is zwitterion will help with fibrinogen, nitric oxide will help with platelet activation. So that's the innovation. Approach, we write some preliminary results and the future work. So here we showed preliminary work, we have done nitric oxide work, but the issue is some thrombosis still happens without zwitterion in that figure. Then we say we have covalently bound zwitterion to surfaces and look how the contact angle changes with zwitterion. It's stable for 14 days. The contact angles remains low for so long. And then we say after we put zwitterion on NO surface, the nitric oxide release is not compromised. We can still release similar amount of nitric oxide. One is with zwitterion, one is only nitric oxide, right? And then we say, but when we did fibrinogen study, my nitric oxide with zwitterion surface, the left one, significantly less fibrinogen absorbed. So zwitterion is also doing its work. Nitric oxide is also getting released. That's it. That's our preliminary data. Now we are saying future plan. Future plan, first I'm saying these are the people work who are co-Is and PIs of the proposal. How different people have different types of Dr. Bartlett, Dr. Laughlin, me, how we have different expertise. I'm an engineer, nitric oxide person. Dr. Laughlin is a zwitterion person and a chemist. Dr. Bartlett is a clinician and a surgeon. How we have the right expertise to get this work done. Then, and see, and I'm not saying you guys must have seen even nicer proposals written, but I tried my best to make it neat and clean and underline certain things, bold certain things, don't overdo it. I tried that. Maybe to somebody it's not that good, but that's should be your goal, to make it as professional as possible. Just so you know, this proposal was not funded. Okay, we can talk about it in lunchtime. Okay, so then the two aims that we are going to do, the timeline, year 1, year 2. Now expanding on those aims. My aim 1 is to make that coating, but my aim is to make nitric oxide around that number. See, if you won't put those type of details, reviewers will have problem, right? If you say I will make nitric oxide releasing surface, okay, for how many days will it release? at what level it will release. So you need to go in that much detail, right? But you don't have to write every solvent and every chemical you are going to use. You don't have space for that, right? We will make nitric oxide surface, we will covalently bind zwitterion surface, we will characterize it. See, I'm not going to, you don't need to read it, but see, I'm just reading from here. We will test at 37 degrees, 7 days is written. So we want the release and coating to be stable for 7 days. For 7 days, it should release at least 1 10 to the power minus 10 flux. You define your coating. I define ZNO is zwitterion NO coating, so I don't have to write the full name, nitric oxide releasing zwitterion. I'll use ellipsometry for thickness, like just enough information so that reviewers can see what you're planning to do. Expected results, I think I'll be able to make this combination coating. We have already made it. We are just going to optimize it to make it a little better. We think the nitric oxide can easily escape through zwitterion coating. Whatever I can think. Potential problem. So maybe zwitterion steps can potentially cause snap leaching. So we are putting snap first and then zwitterion. But when I am putting zwitterion on top of snap surface, there might be leaching of that snap and I might lose some snap. If leaching is greater than 10%, a low water uptake polymer coat will be used. So the point is, you don't need to learn this project, but the point is, you need to have thought about the project well. You need to have thought that what can go wrong, and if something goes wrong, what is your alternate strategy to fix that issue? Aim 2, I will do in vitro study, how I will do protein study, how I will do platelet study, look at, but you also are defining what are your control surfaces here, what will you compare it to, all that. Aim 2, whatever surface, however zwitterion, however amount of nitric oxide release performs the best in aim 1 and in aim 2A will go for animal study. How I will coat the tubing of the animal, and then how many animals will I use, what are the groups, I'll use only NO, only zwitterion combination and nothing as a control. Lot of times we even say we will compare it to heparin coated surface also, because that's a standard clinically used. Lot of times if we don't write that, we get dinged for that type of thing also, that okay, maybe your NO zwitterion is great compared to control surface, but if something is already in market, how will you prove that your material is even that good or not? So you have to propose sometimes that type of surface also. Then in animal study, what data we are going to collect? We are going to draw blood, we are going to look ACT, aggregometry, fibrinogen adsorption, SCM imaging, whatever we will do with. What is the expected result? I feel my ZNO coating will do better than all other coatings. What are the potential problems? Maybe more protein will absorb, I don't know, I'm not reading it that, but you know, you have to think of what is the future impact. That okay, if we are successful, we can coat other devices with it, right? So something that okay, what's the future impact of this type of work? But 6 pages. Another thing is, you cannot see, sometimes what people do is they'll write 3 pages or 4 pages. Okay, that's allowed because 6 pages is maximum, but lot of time that can be looked badly also, that most people struggle to write everything in 6 pages and you are writing in 4 pages. You know, sometimes people change the margin too much. It doesn't happen. Usually experienced people don't do that. But I tell this in the class that I teach, students still try to do it because they don't want to write so much. So they'll make double spaced. They'll make like this big margin. So then it does not look that great, right? So, okay, questions for wrapping up proposal writing, NIH, R21, anything like that.
So, as you told us that this was rejected.
No, this is a different one. That rejected 3 times is a different one.
Okay, so did you get any comments or you try to?
Very good question. Very good question. So, this was rejected twice. So in NIH, you can submit a proposal 2 times, most of the proposals. That 3-time rejection one is a different category. But RO1s, R21s, these type of proposals are, you have 2 tries to get it funded. Now what happens? I like NIH system a lot actually. But still the struggle is, let's say I submit a proposal today. Actually the score was really good. So in this one, what happened? We got a really good score. Okay, let me tell you another thing before that. RO1 proposals in NIH have a published pay line. That okay, if your score is below this or greater than this, you will get funded. So lower the better, right? So maybe for NHLBI, the pay line is 15 percentile. If you are below 15 percentile, you will get funded. If you are above 15 percentile, you won't get funded. It's very black and white. Now, the problem with R21 is the program officer decides if it should get funded or not. Reviewers loved it. We got a really good score. But the program officer said, this is a high risk, high reward project. I don't think so, it's high risk. Now, this is a very tricky thing. If we don't put enough preliminary data to make it look high risk, reviewers might say, oh, I don't even think it's possible. So, how to make it look enough high risk, but don't do so many studies that it looks not high risk anymore. So, reviewers gave us suggestions. Actually, honestly, I don't even think we submitted it twice. We only submitted it once. The score was really good. And program officer said, oh, it's not high risk. Then we thought, what's the point of trying again? Because even if we submit again, the reviewers will review it, but then it will go back to the same program officer. If the program officer thinks it's not risky enough, then what's the point? But you brought a good point. Lot of times, what happens, we submit proposal, getting it funded in first time is almost impossible, okay? I don't remember if I showed you the timeline yesterday. Usually what happens, you submit the proposal, let's say we submit something today. It will get reviewed in 3 to 4 months from now. Then there is a council that meets. So if you are lucky, you will get funds in December or January. It's a 1-year process. But most grants don't get funded in first attempt. Reviewers give you feedback, you resubmit it. Even then most grants don't get funded. Because if I give you a document today to read, right? And I'll say, give me your comments. You give me some comments. Next time, there is a really good chance it won't go to the same people. Even if it goes to you, but maybe by my reviewer number 2 and 3, earlier it was Rashmi and now it's Neha. So people change, and 5 months ago when you read it, in my last submission, you read it with different mindset, your mood was different, your thinking was different, you understood different things, you focused on different things. 5 months later when you read it, your thinking is different. So even if though they address the issues you had last time, you might now bring up some new issues. It happens in our lab all the time, right? Student comes to me and talk to me today, maybe you have experienced it today, also in your labs. You go to your mentor, they say, oh, why don't you try this study? 1 month later, they'll be like, why did you try this? You should have tried that. It used to happen to me, and I used to think, why? And now I do the same thing because so much is going on. Today I am looking at your project with one angle. 1 month later, I'm just thinking something else, and I'll be like, no, 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 you should try that also. You should not have tried that, you should have tried that. So this is the, you need to be really good, but then you need to have a reviewer who really likes your proposal also and is ready to champion, is your champion. So it's a lot of factors, but no matter what, you need to have good science, because NIH has such a good system. There are 20, 30 researchers in the room. A bad science is not going to get passed. You know, even if one reviewer didn't understand the science very well and gave a good score, others will question it, that the score will go down if the science was not good. So
In somewhat sense, they will defend your.
so both things can happen. You know, they can really champion for you, or if the science is poor, they can really say, hey, this person didn't do this in the proposal. And if the science is good, these are the people who will say, hey, this proposal is really good, it can really change things. And these study sections are made up of mixed background people. There might be a chemistry background person also, there might be a lot of MDs also, because it's NIH. So they understand clinical problems better than basic scientists sometimes. So there are a lot of engineers. So it's like very mixed study section. And the SRO, our SRO got up, he or she picks the study section after looking at the proposals also. So if there are a lot of proposals talking about hemodialysis or blood material interactions, the SRO will try to pick 1 or 2 people in that study section with that background. So I really respect the method. The system is really good actually. Okay, any other questions for proposals, grants? Next thing I want to talk about a little bit is your exam yesterday. Now, let me open this, and actually people who are online and live, they can also, this can be a summary of the classes we did. So one of the exam question was define biocompatibility. And the thing is, a lot of people gave good answers, but a lot of people gave very unexpected answers. Define biocompatibility. A novel polymer is being developed. Briefly describe 4 tests to evaluate the biocompatibility of this material, right? So I hope, who will answer this quickly? I just want one 30-second answer. No, I don't know. Okay, what's your answer? Quick answer. 30 seconds.
So we can test for biocompatibility.
What is biocompatibility?
Oh, yeah. So biocompatibility is like the material is stable and is able to perform its function which it was made into. So it should not cause clotting.
Or trigger any problem. Like it should do its job, what it's intending to do, without causing any harm to the body. Yeah.
It should not cause cytotoxicity. It should be only able to perform the function with which we intended it to, and there should be no embolism, no thrombosis or something, like activity.
Yeah. And in biocompatibility tests, she already mentioned some of those, right? Okay, then this one was interesting. A lot of people didn't answer this well. Active and passive antimicrobial coatings. What is active coating? What is passive coating? See, you are all the people who did well in the exam. You sure? You know you answered this wrong. Okay, but you can go for it. Okay.
So sir, I think active coatings are the ones that there is a direct diffusion of the whatever antimicrobial agent we are employing with.
Okay, so active coating is it's actively releasing something,
Yeah, it's like
right? Silver or nitric oxide, or antibiotic releasing surfaces. That's an active coating.
That slippery surface you talked about.
So super hydrophobic surface, super hydrophilic surface, slippery surface. It's not releasing something, but it's passively trying to prevent things from sticking, right? Okay. Okay, biofilms and 4 phases of biofilms. I think everybody wrote phases of biofilms very well. So lag phase, log phase, stationary phase, death phase, and explain that. That's fine. Why biofilms are difficult to eradicate? People didn't answer really well.
I guess I wrote the answer because bacteria, the bacteria inside that biofilm releases some of enzymes that degrade or defunction, like disable the function of antibiotics that are trying to penetrate the biofilm.
Okay.
That they make something free. I don't remember, but they make it then out of which approximately 80 to 90% of the particles get 10%.
Yeah. So EPS, extra polymeric substance, it protects the bacteria in there. Bacteria goes into dormant state. There can be quorum sensing. Bacteria can talk with each other and start protecting each other. Biofilms don't let antibiotics enter it. You need 1,000 times higher dose to go inside the biofilm. So all those things were needed to be discussed. This I think most people answered, so I'm not going to go. The question was properties of surface that affect the interaction with proteins and properties of proteins that affect the interaction with surface, right? TGTM, again, lot of people didn't answer very nicely. Who will tell me TGTM?
Transition to temperature where the polymer is getting from solid state to a rubbery and a soft state is a transition, glass transition temperature, and the melting temperature is where the rubbery states completely change into a liquid.
Okay. What else?
So every material will have a glass
Every material,
polymer.
every polymer. So some people for TGTM gave examples metal and ceramics, right? So polymers will, every polymer will have what? What were you saying?
TG, glass melting temperature.
Yes. But every material might not have TM because TG is associated with amorphous part, TM is associated with crystalline part, right? And TG is greater than TM or TM is greater than TG?
TM is greater than TG.
Yes. So little bit of that needed to be discussed. Numerical problems were very easy, but I think less than maybe 10% did it right. Okay, they were very simple problems. So one was you just had to remember that formula that G is equal to, I don't remember, G is equal to T divided by 3.3 log B by B. That's it. And then the other was G is equal to T over N or something, right? If you just remember that, the only tricky part was forget 8 hours. Let's say I told you guys forget 8 hours. Only tricky part was your starting bacteria count was 500. Your final bacteria count is 310 to the power 6. Time is 6 hours. Just so you know, 8 hours was, now after you had calculated G and N, in 8 hours, you knew the starting count was 500. You know the time is 8 hours. You had to calculate the final concentration of bacteria at 8th hour.
Actually, what I did, like when you told that you don't have to answer the 8 hour thing, so I didn't answer it in the question, but I just how to solve. So I did what I just took the number of generation that I've calculated earlier and the generation time, and I just divide that to calculate the number of bacteria.
I know. Okay. So last question was, the last question numerical was this molecular weight average and number average. Very simple again. It was just, if you remember the formula, sigma Ni Mi divided by total Ni and then sigma Wi Mi. So, and you always remember weight average molecular weight is greater than number average molecular weight. What is the ratio of weight average molecular weight by number average molecular weight called?
Plasticizer.
Plasticizer. Polydispersity index. Okay. What is plasticizer? Now, since you said plasticizer, what is a plasticizer?
When we add plasticizer to a polymer, it increases the TG. No, it decreases the glass transition temperature of a polymer.
Okay, okay, but what is a why do we add plasticizer? So some polymers like PVC are very difficult to work with, because they are so, they can become brittle. So we add plasticizer to give that little flexibility to the polymer, and plasticizers provide that flexibility to the polymer. Polydispersity index. Yes, it's in the slides. It's there. But I know it was too many slides. I know. So it is always greater than 1. Because weight average molecular weight will always be greater than number average molecular weight. Now the next part that is also very important is how to prepare a presentation. Okay. So today my topics are how to prepare a presentation, technology transfer, ethics in research, and finally some tips and tricks for PhD students, researchers that I found were useful. So I want to share that. So this is the whole day plan for today. Okay. So presentation for preparation. How many of you think you are confident in presenting, and how many of you are nervous in presenting? Okay, you guys are confident ones. Okay, confident. So that's, oh, you are not confident. Okay, okay. So, and it's totally fine. Most people are most people are not confident. Okay. Now I'll tell you about myself. So when I started my PhD, my confidence was 0. But while working during my PhD, my mentors were great. They pushed me. I got some opportunities to present. And slowly I learned you have to become confident. And the reason is you might be a great scientist, but if you cannot present what you did well, then people won't appreciate all the good work you are doing. So you can be both. So one is in your not being confident, you might present things in a boring way. Now that's a problem. Audience are not enjoying. Or you're talking too fast because you're not confident, you're nervous. People are judging that, or it's instead of looking at your great science, it's hurting, your nervousness is hurting you more. So I think and I'm going to talk a lot of things, but whatever I'll randomly say without the slide also. One thing you can try to do is record yourself presenting and watch yourself later. You will hate it. Most of us, if we present and then we watch ourselves, you'll be like, okay, how was I talking? This is so weird. I should not talk like this. But it'll maybe tell you that, oh, I say this a lot, or oh, I stop a lot. I have not done it for myself. Okay, if I look at it, I might hate how I do it also. But it might teach you, I say this word a lot, or I say, I mean, you will see things that you'll be like, oh my goodness, I should improve on these things. So finding what you are doing wrong, then fixing becomes easy, right? Another thing that used to help me was write notes for each slide. So for example, you have a 15-minute presentation, you're going to go to a conference and present. I mean, even the confident people can do it also. Lot of times what happen, you either overspeak on a slide or you underspeak on a slide, right? Like I wanted to talk about clotting on that slide, but I forgot. So if you write some bullet points that, okay, on this slide, I will talk about this, this, this. On this slide, I'll talk about this, this, this. Do it few times for your presentations, and then you won't have to do it again. But let's go through some of the things and then we can see what all is helpful for you. Okay, so all of you, what are some of the things and you don't need to tell me details, Just keywords. What is some important things when you're making a presentation and presenting it? You're making a PowerPoint and presenting it. Story. Concise. Story. What else? Figures. Explanation for the figures. What else?
Target audience.
Target audience.
A proper conclusion or summary.
Proper conclusion. Yes. Novelty of your presentation. What else? I mean, you're saying all right things. Okay. Let's go through it. But yes, these are the things you have to think. I have seen this happening. I have some examples for all of this at conferences or here or there. This is common mistakes people make. Reading from the slides. You know, it's already very boring sitting and listening to somebody for hours and hours. And if you start reading from the slides, you can read from the slides also. Then why are we here just reading from the slide? Text is too small. You know, it's so difficult to read when sometimes text is so small. Full sentences. See, I can read this bullet point. Do not write full sentences, or you should not be reading from the slide. Like you can write paragraphs to read. It's very annoying for. So you need to find good bullets without going into full sentences. Crowded slides with complex diagrams. If you have a complex figure, try to put it on a slide by itself. Don't put so much complexity. Another thing that I have liked with lot of good presenters is that they are not trying to impress you, they are trying to inform you. Once you start trying to impress that, oh, I do all these fancy things and very difficult science, yes, great, maybe audience will think also you are great, but if they didn't learn anything, then that defeats the purpose. So if you can go to the level of the audience and try to explain it better, that should be the goal. And they'll automatically get impressed. But if you're just impressing, they won't get informed, they'll just get impressed. No clear story. I work on this field day and night, but this is not your field. If you guys will start telling me what you do, I won't understand 90% of it. So you have to tell me from basics that, okay, we do this because of this reason. This is the problem and this is how we are solving it. So you have to just remember others are not from your field. Even in biomedical engineering, biotechnology, when we go to NIH, all those reviewers are from our field, but they are still from so different backgrounds that nitric oxide is not a common word for them. Or even if it is, they are not chemists who knows how to covalently bind zwitterion to the surface. So you cannot assume that everybody knows what you are doing. Choice of colors. If you have a very light background, don't write with yellow color. If you have a very dark background, don't write with blue or black color. So just make the colors very contrast so that it's easy to read.
Like whenever I present something, so this is the most common mistake that I do, the choice of colors. How can we improve on this?
I mean, so I don't know if you guys liked my slides or not. They were white with black and red. It's just simple. Yes, right? So then, okay, honestly, you don't even have to think too much. If you like my slides, just start making slides like that. You know, just choose the right colors. If you have a white background, don't write with pink color, yellow color, very light colors that will just go mix with that, right? Light blue color. If you have a dark background, don't choose dark colors to write, so that it's at least visible for people easily to read it, right? That's just the goal.
At the very start of my PhD, I was told that RGB colors will be used for presentation. and that is very mandatory.
Yeah.
Give your conclusions in red, you give your results in green, and so that then everybody should catch it.
Yeah. So off topic. So 2 tips for you guys. Do not try to. Okay. Sometimes I get emails from students, postdocs. Email has like 5 different fonts going on. Actually, this should be a topic in the afternoon, but I might forget, so I'm going to tell you right now. Address it to the person you are emailing. Lot of time emails are dear sir, dear professor. So it looks like this person just sent it to 100 professors the same email. Since we are talking about this, and you should be listening to because you are applying, little bit address it to the professor you are trying to apply to or job, little bit relate to their field, then it's like little bit more personalized email, right? Lot of time people want to say, hey, I have made nitric oxide releasing surfaces, I work with antibacterial coatings, I work with hemocompatible surface, I have animal model. But the person they are applying to has nothing to do with it, right? So you can say that, you can say, hey, I have done this, you do this, and I think my experience can be very relevant to what you do. Or I saw your these 2-3 papers in last 1 year, I see you are moving in this field and my background will be very helpful to what you are doing. Since we are on this topic, try to write short emails to the point. Attach your CV definitely. Lot of time people just write email. So you have to remember sometimes professors are getting 100 emails a day. The chances they will click and open your email, sometimes it's tricky. And if they do, you didn't have your CV there. Now I'll say, hey, please send me your CV. Now you're taking another chance that now you send me the CV. Will I open the email again or not? Because what if the day your email comes, I have so much going on, this deadline, that deadline, this emergency, that your email now gets buried in this pile of emails. So short, to the point, definitely highlight your strengths, your accomplishments, but don't write paragraphs and paragraphs. Nobody is going to read that. Just few things. Do try to email again after a week or 2. Give some time, and then it's a little bit your luck now. Sometimes you emailed. See, but again, professors are very busy. Money is a big problem. Funds. So today I'm not looking for somebody. Tomorrow I get a good news that I'm getting a big grant funded. Now I am in a big need to hire 3-4 people. But you emailed me a month ago. Now you are out of my mind. And now suddenly she emails me tomorrow when I got this big news, and I'll be like, okay, I want to interview right now. So luck, be in the right place at the right time, all that matters. Okay, so you cannot fix a lot of things, but you can try your best. So another thing why I went to that topic, lot of time these emails come to me, underline, bolded, italicized, blue color, yellow color, just too much. It does not look professional. Attitude. So be relaxed and confident even if you're not feeling confident. At least pretend that you are confident as much as possible. Don't get defensive. So it can look really bad in the presentation setting, conference or whatever, that people start taking it too personally. If you start asking me, but does nitric oxide really kill 90% bacteria? And I start getting upset with you, or I feel, oh, you are questioning my science or something. You can still address it and say, oh, we have done studies, here is my study. And if it's getting too much back and forth, you can say, this is a great question, but let me finish this and we can talk after this session. Because sometimes Audience can be difficult also, and you answer something and they question you back. You answer something, they question you back. Some people are just either they just want the answer so badly, or they want to criticize. There can be 1% people like that also, right? So don't be disrespectful. Even if somebody is annoying you, irritating you, keep your calm. Don't try to impress, try to inform. No nonsense. It's okay to say, so when you go to conferences, try your best to prepare. But it's okay you don't know something. We cannot know everything, right? You guys asked me so many questions I didn't know. What can I do now? But if I try to give too many wrong answers or make up answers, now even when I tell things that I know, you won't trust me because you don't know now what to trust and what not to trust, right? And show enthusiasm. So sitting in audience and listening to somebody is anyways, so you need patience and everything, and you're listening to somebody without getting bored, 100% attention. If the other person is not enthusiastic with whatever they did, you are going to get bored also. So you need to at least show passion for what you did, and hopefully you can make others excited about what you do. Never exceed allotted time. So I don't know how much you have been to conferences. Some conferences, every conference is on very tight schedule. Some conferences are so big that maybe some talks are happening in this building, some talks are happening in administrative building, some in civil engineering building. This talk is from 10 to 10:30. 10:45, I want to go and attend a talk in a different building. If you are going off time, you are now causing lot of chaos in this whole plan that's going on. Lot of time, the moderators of the session, they actually will stop you also, because if I go 5 minutes over for you, my next person will start late. What if somebody wanted to attend that talk and run somewhere? Now they cannot attend their talk because you were taking more time. Practice beforehand. Be prepared for total technology failure. So I was coming here, right? What if I just brought all my PowerPoint on my laptop and my laptop won't start? Terrible. First of all, I'll get a heart attack if my laptop won't start because everything is on that. But now I came here for 2-week program and my laptop is not working. So before I came, I put all my slides on a flash drive also and on my laptop, so that I have multiple places where my stuff is. I also put lot of times on the cloud, like whatever your slides are, because you never know. My suitcase came a day or two late this time. What if you had first of all, you should have your laptop with you or your flash drive, but what if I had something in my suitcase and now that's not coming? I know most of you know a lot of these things. They sound common sense, but we still make these mistakes, and they can be really, it need to happen to only, maybe if I'm going to 20 places to talk, even if one time it happens, it's a huge problem. Keep your audience in mind always, right? Are you talking to high school students or are you talking with the professors? Are you going for an interview or are you teaching a PhD level class? It's different. When I'm recruiting PhD students, I talk in one way. When I'm teaching in my class, I talk in one way. When I go to another university to give a lecture when more professors are going to be sitting, I talk in one way. Your audience should be interested in your talk. Don't forget the main point of your talk. I purposely try to, especially in class setting, I purposely try to tell stories in between. The reason is you're listening to me on this topic for last 30 minutes. It's getting boring. No matter how I think how exciting it is, it can be boring to people who are not in your field, right? So if I just say a little story, even if you were going to a little bit sleep, that story will wake you up and now you can pay attention in another 10 minutes. So that's the goal. Organize your talk in a way that you're telling a story. So my goal for the class that I taught was this Gyan program, talk about materials, talk about problems, proteins, bacteria, blood, talk about some solutions. So little bit like a story. Story that matters. Include graphics and figures and words. So if you make whole slide lot of words, people can get bored. Okay. If you put some images in it, that can help. Another thing I feel is sometimes it's not possible, but if you stay on one slide for a very long time, that can be an issue also. That's just my thinking. Because if I'm just talking on this slide, you are listening to me, but your mind is, I mean, we are not Swami Vivekanand, that focused person. Our mind can go a little bit here and there, right? But if I change slide, you'll be like, oh, something new. You will bring your focus back here. So usually they say, usually they say 1 minute per slide. Don't take it hard and fast. Sometimes you have to be on a slide for 3 minutes or 4 minutes, sometimes 10 seconds, 20 seconds, 30 seconds. The point is, don't be like running through slides, boom, boom, boom. Don't be like 10 minutes on each slide. Just have a little speed to it, right? Think about the logic of flow. What are you going to talk about? What will make sense? Plan your talk before start making the slides that, okay, how am I going to tell the story? Purpose of presentation is to persuade. Again, I don't know how, one idea per slide, it may or may not apply every time, right? Neuroscience, human beings can hold only 3 to 4 chunks of information at any time. Outline at the beginning, explain in the middle, recap at it. So I try to do, let's say I started talking, but first 3 minutes, Neha was distracted at looking at her phone or something else. She was not, I'm just making it up. Now the problem is, now at 4th or 5th minute, when she starts paying attention, it's out of her, like we are already talking something. So in between, if you can really little bit say, oh, so I was talking how we can put NO donor in the polymer because we want certain amount of nitric oxide release. Now, even if she missed those 2-3 slides, she'll be like, oh, okay, that's what they're trying. So even if some bit in between people go off, they can still catch and keep listening, because otherwise what will happen? You missed the little topic, now your brain is thinking something else, now you're missing the next part, and now the whole talk is waste for you. Before you present, enthusiasm. Why do I care about this? Why should it matter to audience? What is a take-home lesson for everyone? Right? I came here, did the Gyan program, I'll leave. If you retain 20, 30, 40% of the information, that will be great. You know, and I'm not saying things that you can remember and forget after 2 days of taking the exam, that we all do. But can you remember biofilm or infection or clotting or nitric oxide is a solution? It can do this and this. Just retain that type of information for longer time, right? That's the goal. We talked about this already.
I guess every time you tell something, like when you talk, you always add some story with that topic, and that story help us to remind about that.
That's the goal. And I could have told more stories if we were not doing it on recording. There are more stories, but so talk is not your full research paper. See, sometimes, so for example, when we showed that Dr. Robert Latour's paper, I don't need to show you the 10 figures he had in his paper, right? I'm just showing some key things. A little bit off topic again for this. This should be an afternoon point, but I'll forget it. So I'm going to tell it now. Lot of times students, and I think it depends on your mentor, so don't listen to me. You should do what your mentor tells you to do. I don't like when a student is trying to show me everything. So, okay, show me your 1 week or 2 week data. They are saying, oh, I mixed A and B and I made this polymer. And then when I tested for tensile properties, it was really bad. Then what I did? I mixed C and D and that didn't work. But then I did this and this didn't work. But then I did this and it worked. So I think if you're struggling and nothing is working, yes, please tell the whole thing. But don't take 5 slides to tell me it didn't work, right? You can say, I have tried mixing A and B, C and D, E and F. The tensile properties are really poor. Just say on 1 slide. But if you already found out the optimized number, you can just say, hey, I tried lot of different ratios of A and B, but finally, this is what worked. If you're struggling, you don't know what worked, please tell me everything so we can think of a solution. But just you want to show that, hey, I was working very hard. I tried this and this and this and this. Okay, you're wasting everybody's time. You found the solution. We know it must have taken a lot of time for you to figure out this final formulation, so we can skip all that. So but I know it depends on mentor to mentor. Somebody wants to look at everything you tried, but some don't. So that's your more mentor thing. Big images and movies can take long time to load. This was little bit more casual environment, but if you are going to like a big conference or a big talk and lot of big people are there, professionals are there, and now your video is not playing, it can be very embarrassing, right? Or big images are not loading, or you made all the slides on Mac and now at the conference place you have to use this PC and everything is jumbled up a little bit. So it's your responsibility now, right? So if that was a problem, I should have come here and said, hey, I want to use my computer. Or if you invited me here, I should email you beforehand and say, hey, will I be using your computer or can I use my computer? And then accordingly plan for it. And if it's your computer, I should come here a little early, try to play video on it to make sure it's going to play, rather than feeling embarrassed when it's not happening. Always back up. Don't overcrowd your slides. Don't go to the very bottom of the slides. Because see, this room is fine, but there can be some rooms, big auditoriums that people cannot even read here. So you need to think about that. Consider your blank spaces properly. Make the slide aesthetically pleasing, not that you have like something in one corner, nothing on one corner, there is a weird blank space. So all that goes. So you have to be a good scientist, but this is a package deal with that also. You have to do a good presentation, make a good presentation. Everything is important. Don't change fonts very often. I know some of my slides, because there were so many, I didn't have this border on maybe all the slides, but I tried my best that 80-90% of my slides have the border. I tried that 80-90% of my slides have red font heading, and they are all maybe Arial. But if you are changing slide to slide, green color font, red color font, the heading is changing from Arial to Times New Roman to green to blue, it just looks a little bit unprofessional, right? On the same page, this is Arial, this is Times New Roman, that's even worse. Because if my last page was Times New Roman and this page is Arial, maybe you won't remember and it's okay. but still, try to be careful. Don't go below 20 point in text font. At least it's readable to you, everybody, right? So the method they say is go far and look with your fist, and then when you stop seeing it's covering the whole monitor, then see can you read it from that far. Another thing off topic, posters. Be so careful before you print posters, because you will be standing next to the poster at a conference. Any mistake that you will make, it will make you hate yourself so much, because you will keep looking at it again and again that, oh my God, I didn't write y-axis. Oh my God, I didn't put this. So be very careful. Show it to your lab mates, show it to your friends, mentor, that you do not have mistakes. And actually for that, even bigger deal is your manuscripts that you publish. It's so easy because there are so many pages in a manuscript, figures, written stuff. It's so easy to miss something. There is editorial staff, they are doing their best. But as an author on the paper, it's our job to just make sure that we do not have mistakes. You will just feel embarrassed if it gets published with all those mistakes. Don't distract your audience with confusing figures and content unless you have to. Unless your work is that you have to show something, that's fine. Don't overuse bullets. Don't use multiple bullets. Same slide, there is this type of bullet, there is arrow type of bullet, there is just too much going on. We talked about the first one. Don't use shadows also too much. That you have shadowing going on. Again, make fancy slides, make nice slides, but don't make things that are looking confusing or weird. Like, just focus on content a little bit. Another big challenge is the graphs that we put. Lot of time the fonts on those graphs are very small. And then when you put those graphs here, it's very difficult to read those fonts. So it has happened with me so many times. Students publish their papers. Now paper is published, they graduate, they leave, but they never gave me the raw data. It used to happen early. Now I'm like more particular in last few years that I need all your raw data. Now I have to go to a conference or here and I want to show your graph, but I have to copy paste from a PDF. And now I cannot change the font size. Little change in topic. NIH has become so strict now, and India maybe it's like that too, that we need to have all the raw data now for 10 years or something after your project has ended. Because we are using taxpayer money to do the research, we cannot just say, oh, I don't have the data. It's our responsibility to save all the data, whatever work is being done, with the funding from taxpayer money. A lot of times I have seen students forget to put x-axis or y-axis. There is a graph, y-axis is missing, or it's time, but it does not say it's in minutes or hours or seconds. These small details become very important. Dress professionally. Another one, always face your audience. So it sounds common sense, but a lot of time I have seen either people won't even look at the audience, or they'll just look this, or they'll just stand this and present, or they'll only look at one person. They just feel comfortable and they are just looking here, they are not even looking anywhere else. Or unconsciously, they are just looking in one direction and they are not looking at anybody else. Do not be monotonous. Do not do over hand gestures. Do not act nervous. It's not in your hands a lot of times, but try not to act nervous. Somebody told me one time, and I like that point. Somebody said that they are very nervous when they are presenting, but what they have found, somebody even said they don't wear glasses when they go. So now I am not having an eye contact with you. That's making me nervous. I'm looking at you, you think I'm looking at you, but I cannot see your eyes, that's making me nervous. Okay. Somebody even said that in a big auditorium, they look in all directions, but instead of looking at you, above your head a little bit, because here it will tell if I'm not looking at you. But in a big auditorium, if I'm just talking and looking, I'm not targeting anybody's eyes. I'm just looking in that direction without paying attention to anybody. Now the chances are you will feel less nervous. Okay. Another thing I remember when I was a PhD student that helped me. So one of the students just said, timing, carry extra set of batteries. We were having some trouble with the batteries. Okay, one of the rooms is so bad, like when you stand, you little bit move and that projector just, you come in front of it and now your shadow is on the screen. If you're nervous, you know at a conference you're going to present in this room tomorrow, go that day morning or a day before and see the room. If other speakers are presenting in that room, see where they are standing. Just get a little bit accustomed to that area, and I think that helps. Don't block the screen. Some rooms are badly designed that you have to be careful that you are not. Carry extra set of batteries. I felt so bad. I really forgot to bring my laser pointer and move the slides, right? I was fully planning to bring it, but then while packing and everything happened so fast, I forgot to bring it. That helps a lot. I could be like a little bit walking here and talking and move the, maybe for Gyan program, this is better that I'm standing here, not walking around. And I have seen this, I'm not making it up. Sometimes people are nervous, so when they have laser on, their hands shake and then the laser shakes. So even if when you're talking, presenting, people cannot tell you are nervous, that laser pointer will make it look you're nervous. So one thing I have heard people said is use your hand like this and then use a laser to keep your hand steady. Another one I have seen is people are nervous presenting on the stage. They forget to switch off the laser and then they are like moving the laser like that. At least 3 times it has happened. I have seen that happening, that the laser is going in the audience now, because in that nervousness, people can forget, right? Summarize your results, have a take home message, don't use long sentences, have backup slides. So sometimes you're not showing some data, but something you can think can, I mean, it's again being proactive, planning it well. If some question comes, do you have a backup slide to say, oh, yes, I have it. So try to have multiple backup slides, thinking this type of discussion can happen. Make the acknowledgements brief and to the point. Let audience know when you are done. It has happened at least 3-4 times. People finish and they don't say anything. And now there is a weird pin drop silence and nobody knows what happened. So if, let's say, this is my last slide and I say, let the audience know when you're done. And now I just stopped. It has happened. I have seen this happening. So you, in the end, you can say, thank you so much. Thank you for your patience. Thank you for listening to me. Do you have any questions? That's it for today. Say something that your audience know that, okay, wrapping up. And then for this particular topic, here are some useful links. There are so many, there are so many good speakers. Now there is YouTube videos, links. I think I covered basics that can help. You will get these slides. You will get everything. So, okay. Questions from this topic or any discussion or anything? Oh, so that depends on your venue. Right? See, I had to do 28 hours, right? But if a conference is 15 minutes, you will already know your slot. When you get invited also, so in general, if you think from a faculty angle, most places we go for a seminar or invitation, usually it's 1 hour slot. So you do 45 to 50 minute presentation, you have 10 minutes for question answers.
Sir, but if it is basic research presentation and we have not given any time, so it's up to us like how much time we get.
No. But what is your venue? Where are you presenting? Where are you presenting?
In research.
Yeah. But the conference will there is a big agenda, right? So let's say conference, you are presenting it in 11 a.m. session. There are 5 speakers in this session. You are going to talk at 11:20 to 11:40. You will always know what is that length. Nobody is going to invite you or you go somewhere that you have no idea you are giving a 10-minute talk or 1-hour talk.
And how much number of slides to hide?
That's a good question. So, and even I get, after so many years of experience, sometimes it's an issue, right? Sometimes you have too much to cover, sometimes you didn't make enough slides and things went very fast. So, I'll say if you are thinking that 1 minute per slide rule, that can be a good one. Especially if you are talking with your peers, let's say. Now, if you are talking with your juniors or high school students or undergrads, you might be presenting 2-3 minutes per slide because you are explaining things. So it depends on the topic, it depends. That's why practicing beforehand is a great idea, right? So if you know you have to give a 20-minute conference presentation, you practice at home and see how much time it takes you to do it. But I can also tell you, most people I have seen, they say they talk much faster when they go to present. So at home, if you're taking you 20 minutes, you might be done in 17 minutes because in nervousness, you talked so fast. It's journal. I have heard that a lot. Yes. So yeah, I hope I answered. Yeah.
Like, I have to ask something. Like, you have explained your slide, and you asked me to just give a summary based on your presentation. And now I have to come there and have to explain in a summarized way. So how much time should I use or utilize to cover all the slides to give you a summarized way? Like, how can we decide so that this much time I have to get to this slide and this?
Okay. So you're giving your whole presentation, or somebody is saying,
Giving someone else.
let's say a poster session. Is that a good example?
Yeah.
That you came to my poster, I'm doing a poster, and you say, okay, what are you doing? Explain it to me, right?
Yeah.
Okay. So I think shorter the better. Okay, because lot of time in conferences, there are like 500 posters. Okay, today. There might be so many tomorrow and day after tomorrow. Now, you take my 10 minutes, that's too much. So, you can just tell, so I'm going to give you a 1 minute version, but if you really like certain points, I can talk more in detail, right? So you can say, let's say if you'd come to me, I'll be like, so infection and clotting are huge issues with medical devices. Technology in market works to some extent, but these issues are still there. Nitric oxide is an endogenous molecule that kills bacteria and can prevent clotting. We are developing devices, coatings that can release nitric oxide to take care of clotting and infection. But now if you want more details, I'll say, can I explain anything in particular more to you? Because for this one, I made a catheter, I tested it in animal model, and it showed this decrease. That way, because see, a lot of times what happen, you're walking, you're seeing posters, that 30-second will be great for me. Now, if I'm interested in your topic, I can talk more to you. If I'm not interested or I understood it, I can go to the next one because I want to see 200 posters. You know, of course, you worked on it for 2 years. You are passionate. You want to explain everything about your research. But other person's time is important also.